All right, in today's lesson, we're going to be looking at some more implicit differentiation questions. So in the following question here, we want to evaluate the integral of 4x cos acting on 2 minus 3x dx. So first thing to do here is to remind ourselves of our implicit differentiation formula. And we have the integral of u dv is equal to uv minus the integral of v du. So I'm going to go ahead and choose our substitutions, what I want to let u equal and what I want to let dv equal, giving us the following. Going ahead and doing those substitutions, I'm going to go ahead and let u equal 4x, and I'm going to let dv equal the cos of 2 minus 3x dx. Doing so, we get du is going to equal 4 dx, and your antiderivative of your expression here is going to be negative 1/3 sine of 2 minus 3x. Substituting this into our formula, we get the following. We end up getting here, this is our u times v minus, we have the integral of v du. So now we know our integral that we want to solve for can be expressed as follows. We only have to now take the integral of the following function. So first thing I'm going to do here is I'm going to pop out the negative 1/3 and 4, giving us the following. And going ahead here, I took that minus 1/3 and the 4, put it outside, the two minuses become positive. Now we have the following expression that we want to take care of. I just have to find the integral of the sine of 2 minus 3x. I know that the integral of sine of x is negative cos of x, so we have the following. And end up getting here 4/3 times negative cos of 2 minus 3x times minus 1/3 here. And you'll notice I had to add in the minus 1/3 because when you go ahead and take your derivative, just to show you, we do get the sine of 2 minus 3x. If I take the derivative of the cos of 2 minus 3x, that's going to be negative sine of 2 minus 3x. So the two minuses come together, making this positive. And then the chain rule kicks in. You have to take the derivative of the inside, which is minus 3. So to negate that and get that out of the way, I have to multiply by minus 1/3. So now I've gone ahead and taken my integral here. Cleaning this up, we get the following. Negative 4/3 x sine of 2 minus 3x plus 4/9 cos 2 minus 3x plus some constant value c. All right, let's take a look at another example. All right, in the next example here, we want to evaluate the following definite integral. So now we actually have our integral bounded from 6 to 0 of the following expression here. We're going to solve this using implicit differentiation. So first step here is to define our u and dv value. So I'm going to go ahead, I'll let u equal 2 plus 5x and our dv equal e to the 1/3 x dx. Doing so, we get the following results. I have my u value is 2 plus 5x, and my dv value represents this right here. And therefore, the derivative of u is going to be 5 dx, and the antiderivative of e to the 1/3 x dx is 3e to the 1/3 x. And again, remember the derivative of e to the x is itself. So now that I'm in this situation here, I can go ahead and substitute in my implicit differentiation formula. So this is going to equal u times v minus the integral of v du, giving us. So going ahead and evaluating this, we end up getting here 2 plus 5x times 3e to the 1/3 x. That's being evaluated from 6 to 0 minus the integral of 6 to 0 of the following function. So now to evaluate this definite integral, we just now have to go ahead and tackle this problem here. This integral is much easier to evaluate. So I'm going to go ahead and that 3 and 5, I'll pop that out, and let's reassess what this looks like. All right, you see here, I went ahead and took the 3 and the 5 and popped that out. And now the only thing that we have to do is evaluate this integral here, and then we assess the entire result from 6 to 0. So let's go ahead and do that. So you see here, I went ahead and took the integral of e to the 1/3 x, and that is going to be e to the 1/3 x times 3. And again, the reason I did that is because if I go ahead and take the derivative of this, the derivative of e to the 1/3 x is itself, times chain rule kicks in, we get a third there. So I have to put a 3 up on the top there so we get cancellation. You get that coefficient of 1 that we have here. So we're going to go ahead and evaluate this expression from 6 to 0, giving us the following. All right, you'll see here I went ahead and distributed this expression to the binomial, combined together the 15 and 3, giving us the following expression. We also have like terms here. I have a 6e to the 1/3 x and a minus 45e to the 1/3 x. That comes together to give us minus 39e to the 1/3 x plus that 15 xe to the 1/3 x. So I'm going to go ahead and evaluate this from 6 to 0. Subbing a 0 into the expression, we end up getting negative 39 plus 0 minus, subbing a 6 into this expression, we get the following number here, minus 39 becomes e squared because you're taking a third times 6, and then 15 times 6, and again you get that e squared. Simplifying, we get our following final value as negative 39 minus 51e squared. All right, let's take a look at another question. In the final question here, we want to calculate the indefinite integral of 3t plus t squared times sine of 2t dt. So again, we're going to solve this using implicit differentiation. So I'm going to go ahead and I'm going to let u equal our 3t plus t squared, and I will let dv equal sine 2t dt. Go ahead and doing that, we end up getting here our u value, as discussed, is 3t plus t squared, and our dv value is sine of 2t dt. If you go ahead and take the derivative of u with respect to t, we end up getting that du is 3 plus 2t dt, and the antiderivative of our sine of 2t is going to be minus 1/2 cos of 2t. So let's go ahead and sub that into our implicit differentiation formula, giving us the following. So substituting this into our implicit differentiation formula, we end up getting u times v minus the integral of v, and this is our du value right here. So now we only have to calculate the integration of this expression. But again, this requires implicit differentiation. So we're going to go ahead and let's first pop out this minus 1/2, get that outside of the integration symbol, and then let's do implicit differentiation again on this expression. So going ahead here, I ended up letting u equal 3 plus 2t, and I defined dv to be the cos of 2t dt. Therefore, the derivative of u with respect to t is just 2t dt, and the antiderivative becomes 1/2 sine 2t of our cos of 2t expression. So now we're going to go ahead and replace our integral of u dv with uv minus the integral of v du, giving us the following. And going ahead and substituting that in here, we have our uv minus our integral of v du. We now finally have an easy integral to evaluate. So I'm going to go ahead, and you can see right away the 1/2 and the 2 will cancel. And we just have to go ahead and calculate the integral of sine of 2t. So going ahead here, the integral of the sine of 2t is negative cos 2t times 1/2. Going ahead here and simplifying this, we get the following. I'm going to go and distribute this half into this expression, and we get our final answer as minus 1/2 3t plus t squared times cos of 2t plus 1/4 3 plus 2t sine of 2t plus 1/4 cos of 2t. And you'll notice here the two halves came together to give me my quarter. These two minus signs became positive, and once again, when I distribute that half times this 1/2 here, we got our quarter again. So this becomes the final answer for our integral of 3t plus t squared times sine of 2t dt. All right, that concludes today's examples on implicit differentiation.